slope graphically, find the slope using 2 points, and relate slope to a real world situation. So just looking at rate of change before we go into graphing some lines next week. So it just says recall that slope is just the rise over the run. So if you use a slope triangle off a graph, that might be helpful. So here's just some graphs of lines. So you need to find the slope. So I gave you a couple points. So you start at the point on the left, you figure out how much you have to rise and how much you have to run. So you always start on the left and go to the right, like you're reading a book. So how much did I rise and how much did I run? What do you think the slope is of that line? Yes. Yep, we rose 3 and we ran 4. So my slope is 3/4. If it's a fraction, you could always reduce it if it's reducible, right? So that you remember that. And positive lines, as you read it from left to right, go up. And negative slope, as you read it from left to right, go down. So this is going to be a negative slope because I go down how much and over how much to make my slope triangle. So I go down 1, 2, 3, 4, and over 1, 2, 3. Is it 4, 5? Down 4 and over 5. So negative 4/5 slope. On part C, I didn't give you some dots. So let's see. If I pick this dot, where's the next coordinate that goes through the grid line? Probably here. So what would be the slope for this one? What's your rise? What's your run? I think it's -1/2. And if you went to this point over here, it's down 2/4. So either way, it should reduce to a slope of -1/2, because down 2/4 is the same as down 1/2, 1/2. All right, so that's the first thing you need to be able to do. Part 2, if I give you 2 sets of points, this tends to be more challenging for students. If you plotted them, you could probably find the slope triangle. But when you just have them algebraically, remember this formula? y2 minus y1 over x2 minus x1. All right, so I usually just start with my second point, and I use that as my y2. So I'm taking 4, and I'm subtracting 5. So 4 minus 5 in the numerator. And then I'm going to take this point over here, -2, and subtract 0 in the denominator. And then I'm just going to simplify the fraction to find the slope. So my slope would be -1 divided by -2, which is what? A negative divided by a negative. I'd like you to show that it actually is a positive slope. Don't leave your answer with a double negative. Do you want to try the other two, or do you need some help trying it again? Do you recall this or not? Think you can try it? No one's talking. All right, you try B and C, and then I'll put up the answer and unpause. Right. All right, so I just like to circle my 2's. All right, so I'm going to take -1 and subtract 3, and then I'm going to take 5 and subtract 8. I get -4 divided by -3, so I should reduce that to +4/3. Was anyone with me on that? If not, it's just going to be a skill that you've got to practice. So you might have mastered slope from a graph, and we just have to practice slope from 2 lines. That's okay. Why is C different? 5 minus 5 over -3 minus 6. What does that give me? 0 over -9. So you need to know, can you take 0 and divide by a number? You actually can do this problem because 0 divided by -9 is just 0. So this line has a slope of 0. Does anyone know what a line looks like when it has a slope of 0? It is straight horizontal line. So if I had gotten the reciprocal of this and instead I had gotten -9 on top and 0 on the bottom, do you know what that slope is? Nope. Are you allowed to divide by 0? Does this look okay? So because it's a fraction, you can't have 0 in the denominator ever, and your calculator will tell you, error, you can't divide by 0. So I just think of it as kind of the fraction has nothing to rest on if there's 0 in the denominator. So denominator 0, bad things happen. So we would call this line undefined, and that's actually a vertical line. So when we start graphing next week, we're going to look at horizontal and vertical lines and what they mean. All right, but for now, we just got 0 for that one. Question? I would prefer 4/3, even though 1 1/3 is not wrong. Why do you think it'd be easier to leave my slope as a fraction? One improper fraction. I can see the rise and I can see the run. If you have 1 1/3, it's a little bit harder. Are you actually going to go up one grid line and a third and try to guess where that is? To me, it's easier to graph 4/3. So I think that's a really good question. This would absolutely not be the wrong answer. That is the slope of the line, but graphing wise, 4/3 makes your job a lot easier when you're going to graph a line. All right, next. All right, so we found it graphically with 2 points. This is the last one, thinking about rate of change. A climber is on a hike. After 2 hours, he's at an altitude of 400 feet. And after 6 hours, he's at an altitude of 700 feet. What is the average rate of change? How much has he gone up? How many feet did he just change in altitude? Yes, 300. He's gone a total of 300 feet in how many hours? Yep, if he marked it at 2 hours and 6 hours, then 4 hours has passed, right? So you take how far you've gone and divide by your time, and that'll give you your average rate. He's hiking about how many feet per hour, would you say? Can anyone do 300 divided by 4 in their head? Do 300 divided by 2 divided by 2. So his rate, he's going about 75 feet per hour in altitude. That's not like he's walking 75 steps. His altitude up the mountain has changed 75 feet in 1 hour. And I'm not exactly sure. Yeah, I mean, I don't know the altitude of Mount Washington Valley, but the top of Mount Washington is what? Now I'm blanking. 60 to, now I gotta look it up, guys. Hang on. A scuba diver. Did you know that if you ascend or descend in the water, you get what's it called? The brakes? You get something bad if you go down too fast in the water because of the pressure. A scuba diver is 30 feet below the surface of the water 10 seconds after he entered. And then he's 100 feet below the surface after 40 seconds. What is the scuba diver's rate of change? So he went from 30 feet to what? 100 feet. So he changed 70 feet in, 10 seconds to 40 seconds is 30 seconds. So this one, let's just find the decimal. What's 70 divided by 30? Yep, so 2 1/3 feet per second. And you could make the argument to make it negative because he's going down in the water, but so negative 2 1/3 feet per second. And I am not a scuba diver to know the safe time. Like after you descend so many feet, like in, way down, you have to wait so many seconds. You shouldn't go too fast. Yes. Do you know what it is? Do you know, it is? Okay. Okay. Decompression sickness. I wonder what the speed is to avoid decompression sickness. See how much we can learn from word problems? All right. What about a rocket? A rocket is 1 mile above the Earth in 30 seconds, and then it's 5 miles above the Earth after 2.5 minutes. What's the rocket's rate of change in miles per second and miles per minute? So let's do it in seconds first. So if I'm at 30 seconds, 2.5 minutes is not going to work for me. How did you get that? You're right. How'd you get 150 seconds? 2.5 times 60, right? That's right, isn't it? 2.5 minutes times 60 seconds would be 150 seconds, right? Right, but right, we'd have to subtract the two, right? Okay, so they've gone a total of what? 4 miles in 120 seconds. Yep, thanks. How many miles per second? Not very many, right? 0.033 miles per second. So what about miles per minute? Do you know how to figure that out? How can I change miles per second into miles per minute? Yes, perfect. So I'm going to take my answer times 60. So it's going 2 miles per minute. Then you've got both of the rates. I actually think they usually measure the speed in feet per second, and that would seem more impressive, right? Yep. Because if you're going this many miles in 1 second, I could multiply the miles times 5,280, right? It's going 176 feet per second. That's pretty fast, right? All right, what about this? A teacher weighed 145 pounds in 1986 and weighed 190 pounds in 2020. What's the rate of change in their weight? Why don't you do that one yourself? And then you're going to try the 3 problems at the bottom by yourself. Increase. If it helps you to, use units, this was their pounds and this was their what, years? They're getting 1.3 pounds per year